So I'm working on what I call the action node, and it's kind of ironic because this uses events much more like CBus does than LCC. So what I'll do is hook up to multiple I2C peripherals. So it can use its own native pins, and it can talk to a 23017 or a PCA 9685 or two little units from M5 stack, an 8 servo, which gives you 8 channels of servo, but it also does I/O and all sorts of other things. And another one called PB Hub, which is very similar. It has 12 channels and can do servos, I/O, analog I/O, and it can even run chains of addressable LEDs. And then the last one is the smart nanos. It's basically you just program a nano to be a peripheral. So different peripherals have different capabilities. So native can do almost everything. The 23017 can only do digital I/O. The PCA 9685 can drive servos, but you can also use it to drive LEDs, which is kind of nice because you can set their brightness levels. The 8 serial can do almost everything, as the PB hub can do almost everything. And then the smart nanos can do anything the native thing can do. So I program digital out. You can have parameters like we had before. So 2 phases, and then you can have on duration, off duration. So you can do solid or flashing or single pulse. Analog out has a fade speed and a target brightness. So you can have slow on, slow off. Servo out has speed and target angle. Color has flash rate and the color index. Right now, I've just you can choose from red, yellow, or green or off. And then there's other ones like double strobe, fire, welding, and random effects. Um, so you can also do inputs. So those are all outputs. You can do inputs. So digital in, and then you can tell it to do a delay before it actually sends the event out, which is what John used in his crossing gate to delay the raising and lowering of the gates. Analog in has a level window, so you can say send an event out if the analog value is between two levels. And then I've defined some modifiers, which is sort of a new concept that I thought up. One is set pin. So it'll watch. So you can set a servo channel, and then you can tell this one to watch that servo channel. And if the servo moves past a certain position, then it'll turn the pin on. And if it comes back the other way, it'll turn the pin off. So you can use that for your frog switching. And then there's one's called watch, which watches a channel and produces events. So you can set that on a servo output and then tell it to set an event if the servo does this or or goes below a level or goes above a level. And then there's ramp modifiers, which you can actually tell it to change the parameters of the other channel. So you could change the brightness of an LED, say, over time. And then so the actions are kept in storage, and they have parameters are which peripheral you're talking to, which channel do you want to talk to, what's the effect, and then each effect has two parameters, P1 and P2. And it also has an event ID, and that either gets sent or received, depending on whether it's an input or an output. So for outputs, obviously, when the event arrives, it performs the output. And for inputs, when the input does whatever you want it to do, it'll send the event. And then actions get translated to effects in the RAM. So they get loaded into RAM. And output channels can have multiple actions on them. So you could have an output that one event turns it on, one event turns it off, one event makes it flash. The same for servos. One event puts it to one position, then another event puts it to another position. A third event could put it to a third position. And then input channels can have multiple active events all at the same time. So you could actually watch the same channel and produce multiple events for when it changes. And then the modifier effects sort of run next to all these and change things. So I've got a demo set up here, which I'll show you in a sec. And it's got a Mega 2560, but it could have been any processor, basically. It's got a servo and some LEDs attached to it and a LED ring. I've got a PCA 9685 with a servo and an LED attached, an 8 servo unit with an LED and an addressable LED attached. And then that's the end. So on to the demo. So here's the setup. Here's the Mega 2560 is connected to this ring, which is addressable LEDs. It's also got, I also drive the built-in LED that's down here. And I'm also driving a white LED, which you probably can't see at the moment. It's here. And then through I2C, I'm going through these little distribution boxes here that come from M5 Stack. So I've made an adapter. I can plug it in, and then you can plug all these other things into it. So it's kind of handy. So over here I have PCA 9685 is connected to this servo and to an LED. I've got an 8 servo over here connected to an LED and an addressable LED. This little guy down here is called the PB hub, and it's got 6 channels. Each channel has 2 pins that you can drive for most things. What else have we got? Anyway, so down here I have some actions defined. So this is just a demo, so it's not in a node. It's just me trying to develop all the software. The software, the way I've organized the software is the special effects are built into the main class called peripheral. And then these call things that actually set and reset the actual pins on the device. So I've got a set digital, get digital, set analog, get analog, set servo, get servo, detach servo, set color, etc. And then those are specialized in each of the peripherals. So down here, I've got a native class, which is a subclass of peripheral, and it drives all the native pins. So it has its own copies of what set digital does. So set digital is pretty simple. It sets the mode of the pin, and it uses digital write to set the pin, and so it goes. So down here, I have some actions defined. So I can type in here on the line. If I type in C2, it'll run the second one here, A2, which is a digital out phase A with the parameters 5, 5, and it should flash. So it's flashing this LED down here. And if you type in C3, it'll flash it slower. And C0 is defined to turn it off. So it turned off. Now, let's see what else we got here. So A4, oops, C4 will turn this servo over here. Watch. That jump at the start I need to fix, and then if I do C5, it'll go to a different position. And if you notice on my screen down here, it says send PCR. Is sending a event as it crosses 90 degrees because action 7 and 8 are cross actions. And then if I activate C5, C6, I think it is. Yes. C6 is a set pin. So if I activate that, now this LED's come on. If we move the servo back, that light goes out. So that would be setting your frog. If we do it the other way, it'll set the light back on. There we go. Then let's see what else we got fire. So let's see if these work. I was playing with these this morning. Well, that didn't work. Let's try C10. Oh, something's gone wacky here. That's the trouble with demos. Nothing ever works. C11. So this is random. This randomly turns that LED on and off, and you can set how long it stays on and how long it stays off between. So if you picked, say, 10 seconds, it would choose a random time between 5 seconds and 10 seconds. If you picked 40 seconds, it would pick between 20 seconds and 40 seconds. So let's see if I don't know why. Yeah, I broke something. Sorry, guys. It was supposed to be trying to do fire, and oh, there's welding, I think, is working. So it welds for a bit, and then it turns off for a bit, and then it welds a bit more. And again, you can set the length of how long it welds and how long it rests between the welding. So then we have pin 2. Oh, so we can turn. So if you look at A12 and A13 there, they should turn on that LED slowly. Yeah, so much for that. I don't know what's happening there. Let's try C13. Lost it. Don't know. So let's do C14 should turn. This is the servo being driven. This servo is being driven through the PCA 9685. So if you look at A14 and A15, you can see it's servo out going to peripheral number 1, which is the PCA 9685. So we can move it back to the other side. And then let's see, peripheral 1, I've got some at the bottom here, C25 and C26. So that's turning on this LED using the PCA 9685. And we can turn it off again. And it does a slow dim. So that's kind of nice. And then if we look over this side, we can that's the peripheral 2. So C21 through 24 talks to that. So let's see what they do. C22, I'll try. C23. So C23 turns that adjustable LED to red. C24 sets it to blinking red. And C21 should turn it off, I think. Yeah. Oh. Oh, I've set the other one blinking now. 20. Yeah, I don't know if I can turn that off. So that sort of shows you that you can get all those effects through I squared C to a bunch of different peripherals. And I will continue to add to the peripheral key. Oh, the other thing is I haven't set it up on here, but native, maybe I can show you in the code here. you just you've defined your pins, and then you call native, and so you can make multiple of these. So on this board, you might also make some new pins and then have native 2 as a separate peripheral if you like. And then you can have multiple MCP 23017s, multiple PCA 9685s, and so on. So, if you wanted a ESP32 with two 23017s on, you could easily do that. Okay. Any questions?
So at the moment, obviously, this is the proof of concept in it, what we can do. Obviously,
Right.
they will be the variables that you would change within JMRI, I take it, yeah?
That's right.
Yeah,
Yeah, yeah. So in Jeremiah, you'll say, I want to set up this pin on this peripheral. So you'll choose the peripheral and you'll have a list of them. Then you'll choose a channel. Then you say, this is what I want the channel to be able to do. And when you choose that, I'm hoping that we can change the screen so it gives you the options, basically the parameters for that type. I'm working on that with Grok. It's very frustrating. Changing JMRI.
yeah, because we've actually got the ESP32 with one MCP 23017. So it might be a
Yeah.
case of modifying that sketch to get the second one in, and then have a little look the PCA 9685 on that. Obviously, I'll try and bring over the actions as well, maybe on that sketch from what I've
I
got
forget.
on the Mega. But that's where we're trying to go from it. Obviously, the issue with the servo on the PCA 9685, that going to 0, there is a way around that, but I can't remember off the top of my head what it was now.
Dave, how do
Oh,
you
I
see
forgot
it being
forgot to
used?
show you the ring here.
Yeah.
So here's a ring of addressable IDs, and you can basically set any of them to anything you want. So that's yellow, and then I think 19 is flashing yellow, and 20 is green. So obviously you could run your signals with that.